What's going on, guys? So this is the progress on the Arduino robot here. I've got all the circuitry attached and there's a few wires hanging off, but really the bulk of it are the servo wires, and then you have some wires here going to the servo controller from the Arduino Nano here. But pretty much I just have it rotating right now, and I'm plotting the motion data. So the motion sensor, I actually got it right about the center of the robot, sort of, you know, pretty good. You can see the green light in there's the motion sensor. So that data is coming out and being plotted on the screen. And so I don't actually know what each of these plots corresponds to, because I have 6 axes. So I have acceleration in X, Y, and Z, and I have gyroscopic motion in X, Y, and Z. So there's 6 measurements that are being plotted here on the screen. But I would hope that gyroscopic motion, you know, rotational motion in the y-axis, if this is the y-axis, is the gray line, because you can see that it's following it fairly well as the robot turns in that direction. So if I pick the robot up so that it's not controlling its own movements, you can see that the motion data is completely chaotic right now unless I hold him fairly still. So if I turn him left and right, let's try like a slow left and right. Yeah, that's the gray line there. If I go back and forth, that looks like it's blue mostly, and this way looks like red possibly, or orange. Orange is in that direction. Purple is front to back. Gray is left to right. And then I have acceleration, so it'll take some experimentation to see which ones correspond to my acceleration here. So also you may have noticed that the robot is tethered. I have power going through this white and orange line here, and that goes to the servo controller, and I'm just powering it with this cheap 2 amp power supply, 5 volts. Then I have power and data going to the Arduino Nano, and that's through this blue USB. This is one of the this is one of the detriments of having the guy tethered, is you have all these cables, right? But it's also nice because I can just send data right over to my computer to record it, because ultimately this is like a data collection platform. So I'm gonna have it perform certain actions and kind of record the data that I get for that, and then try to promote actions that lead to movements that I want, like let's say forward direction or levelness, or some sort of spinning or turning in a certain direction. And then I'll be able to kind of save those movements. I can condition it on a specific action, like let's say I want it to move forward, so I'm going to condition it on moving forward, have it try out some random actions, and learn the best actions to move forwards. And then when I want to control it, I can just pick, let's say like it's a vector of 1s, I could just turn the slot on that corresponded to move forwards, right? And it should perform those actions. So we'll see though. I think that's it for now. Pretty much my first time doing any sort of PCB stuff, so it's a little bit sloppy back there, but it gets rid of a lot of wires from the Nano, and yeah, just a lot of 3D printing. I got some other battery cells I may try out when I want to make it not wired. and perhaps some sort of wireless connectivity, so that ultimately when it learns how to move around well and I can control it, or I put some sort of autonomous other sensing on it, it can just kind of go out and explore and live its life, you know? It's got to get out there and just, it's got to make its own way in this world, you know? It's got to get to work. So this is the first kind of baby steps. All right, thanks for watching, and I'll see you in the next video.